Hi, it's Robin. I saw my patron Shaun Bebbington post about a coding challenge. It's on the website stackexchange.com in a section called Code Golf. Now, Code Golf is a competition to solve a particular problem in the fewest bytes of source code, and what's neat is that they accept and list solutions from many different languages. There's nothing preventing unusual or old languages, like Commodore BASIC, from being used in the challenge. Turns out I've been playing a lot of Code Golf over the years, and only more recently learned the term. So this particular challenge is to write a program that outputs the color of a given square from the chessboard. So now, rather than use their diagram, I wrote a little program that just prints out a chessboard. So this is how the chessboard looks. The letters A through H are across the top and the bottom, and on the left and right sides, the numbers 1 through 8. So any particular square can be referenced. And you notice that down in the bottom left corner, it's a dark square, and then it alternates in this classic checkerboard or perhaps chessboard pattern. And it's a dark corner in the bottom left and all the way up in the top right. So this particular challenge was posed way back in 2015 by user Adenin. Okay, so the rules are you need to provide a full program that uses standard in and standard out to output the string dark or light. Now, today we're going to be using Commodore 64 BASIC. Standard in is essentially the same as the input statement, and standard out is print. So if we type in B1, then it's going to output the word light. If we input G6, then the output is also light. And if we input square D4, then the output should be the word dark. So when we type in B1 or whatever, we can assume that the input is always going to be valid. That is, we don't have to check for somebody typing in ZZ or hi or whatever. And with it being Code Golf, it's the shortest amount of bytes wins. Shortest amount of bytes. Should that be smallest amount of bytes? Anyway, the minimal amount of bytes. Now, in a tokenized language like C64 BASIC, bytes of source code can be interpreted a couple different ways. I'm going to go with the number of characters entered from the keyboard, so basic shortcuts are allowed as long as you can type them directly in. Now, even if C64 BASIC expands it upon listing, I'm going with the number of characters input. Just that makes it more interesting and shorter. Okay. And there's the listing of the program I used to generate that little chessboard. I won't go through that, but just pause the video here if you want to look at that in more detail. I'll leave that in memory in case I feel like referring to it later. I'll just use run 500. Okay, so for our program, I'm just going to write a long version of it first. We're going to input a string, and that will be the input, the standard in. What we're going to do is split that up, that input, into an X and a Y coordinate. So if we take the ASCII value of the left string of a string, comma 1, so that means take the leftmost single character and close the brackets, and we're going to subtract 64 from that. So, for example, if the input was just A, that returns the Petsky code for the letter A, and you see that's 65. So we want to change that A into an X coordinate from 1 to 8, so we subtract 64. If it was C, that should return 67. If we subtract 64, that should return 3. There we go. Okay, and Y is a little bit easier. We're just going to take the value, which converts a number in string form into a actual numeric value. And we can just take the right of that string, the rightmost one character, and again, close the brackets. So that's easy. So let's just print out X and Y and make sure we have that working right. And I'm just going to make sure the program ends at 490. Okay, here we go. Run A1. It should output 1, 1. Good. H8 should be 8 and 8. And C5 should be 3, 5. So if instead we just change this to 1 through 8, so there's a property of a chess or checkerboard that will come in very handy for when determining if a given square is dark or light. If you notice here, the X and the Y are each 1. So 1 plus 1 is, of course, 2. And you see how this dark stripe runs up the diagonal here, all the way up to 8, and 8 is 16. Each of these diagonal stripes, if we start this one here, here's another dark one. This is 3 and 1. We add those together. Have you noticed how so far every dark stripe is an even number? So here's one where the numbers are 6 and 4. That's 10. That's even. Anywhere you go on the chessboard, this holds true. And likewise, if we go here to this light square, 2 plus 1 is 3. That's odd. Shift up. 3 plus 2 is 5. That's odd. 4 plus 3 is 7. That's odd. And so on. Figuring out if something is dark or light is just as simple as determining even or odd when you add the two numbers together. Okay, so rather than line 40, we won't print that out anymore. Instead, we're going to just add X and Y together, just like we've been doing. And to figure out if it's even or odd, you just do a AND of 1, which will return either 0 or 1. 0 if it's even, 1 if it's odd. It's just binary math. Okay, and then we can just do something like if A equals 0, then print dark. And if A is 1, then print light. Let's test that out. B1 is light. G6 is light. That G6 looks like a 6-6, doesn't it? D4 is dark, and A1 should be dark, and H8 should be dark, and H7, one below it, should be light. Okay, so our program's pretty good, but lines 50 and 60 are a problem. We're doing if and then, and the problem with if and then is that if it's false, the basic interpreter automatically drops to the next line. It does not continue to execute any other code we might have after that line. And if you use an if and then your program must be longer than one line. And I think we can get this down to just one line of Commodore BASIC code. But to do that, we have to for sure get rid of the if then. So how do we do that? Well, let's delete 50 and 60. What we can do instead is print out mid-string. This is a trick we used in that 10-line adventure program long, long ago. We can combine the two strings into one string, put dark and light together in the string, and then we can take A, which is either 0 or 1, multiply that by 5, and because the mid-string expects a 1-based string position, we'll add 1, and we'll print 5 characters. So if A is 0, then it'll be 0 times 5 is 0 plus 1. So either we'll be in position 1 of the string, or if A is 1, then it'll be 1 times 5 is 5, plus 1 is 6, position 6, 1, 2, 3, 4, 5, 6. There at the start of that word, and we will print 5 characters from that position. So either dark and a space, or light. So let's try that. A1 is dark. B2 is dark. H7 is light. Okay, so let's try one-lining this. Can we get it to fit on one line? We're going to use line 0, as is our tradition, the first line that's possible. We're going to input a string, and of course we're going to get rid of all spaces. I guess I could get rid of that one too. So that's the same as before, except we're just going to get rid of that space. Here's an interesting thing. If I type in line 1, you might think that I-Shift-N is an abbreviation for input, but look at what happens here. I-Shift-N, a string, list line 1, it puts a number sign there. That is the file-based version of input. And when you abbreviate input in Commodore BASIC, this one with the number sign, the hash, appears instead just because it's first in the list of keywords. So, unfortunately, that will not work. You can't abbreviate that word. Actually, I'm not even going to worry about the abbreviations too much right now. We'll do them more, but I'll leave them out so it's a bit more legible. Okay, now we're going to print out the mid string. So what we're actually going to do is go to line 50 and work kind of backwards to one-line this. So we want to print out the mid string, and we'll do that same dark, light. Now we have to give it the starting position, which is this bit down here, a times 5 plus 1. So really we're going to work line 20, the ASCII line in here, ASC, left string, a string, comma 1, and we're going to add in the y, which is in line 30, without the actual variable, the val of right string, oh, I forgot the minus 64, and it with 1, oh, we're getting close here, and then we're going to multiply it by 5, add 1, we're back on the end of line 50 now, and print 5 of them. Ooh, it just fits. Here we're going to end. Here, let's list that up to 5. Did I miss anything? Let's try it. Run it. A1, dark. A2, light. Good. B1 is also light. H8 is dark. D4 is dark. How about D5? Light. Good. Okay, so there is a one-line version. But you notice that's gone a bit overboard here. When you print it, it exceeds 80 characters. And even when it was input, it was, what, 70, 77 or something like that. I think we can make it shorter. So the first thing we can get rid of is that this minus 64 actually serves no purpose because we're reducing it to even or odd. That minus 64 makes no difference in that calculation. If it was odd, it will still be odd. If it was even, it'll still be even. So we can actually just get rid of that minus 64 right away. Oh, here, we're at the limits of the screen editor here. Okay, let's list that again. All right. And just to show that that still works, A1, H8. Good. Okay, so at least now we got down to 80 characters when listed. So there's one other kind of big breakthrough we can do here. An interesting property of ASCII, of the ASC, is that actually it only takes the leftmost character anyway. Like if we go like this, print ASCII, we had already done this, A, it prints out 65. Even if you do a bigger word, really it's meant to just return the character code of a single character. So even if you give it a bigger string, it only uses the leftmost character. So that is a huge benefit for us here. This whole business here with left string and A string 1 and all those brackets, we can just totally get rid of. A string, there, I think I got that balanced. Okay, did I get that right? We'll run that again. A1, B2, B7 should be light. And the one other thing we can do, it only makes the listed version longer, but we can just change right string into mid string. But mid string starts counting from the left, so we'll just specify character 2, and it'll take all the rest of the string. In case you don't know that, mid string has two forms. There's a 2 or a 3 parameter. The first parameter is always the string. The second one is the starting position from the left, 1 based. But the third parameter is the number of characters to take. If you don't specify, it takes all the rest of the string. It's actually pretty handy. So this just takes the rightmost character, and it just makes the listed version slightly shorter. Okay, so that's as short as I could get it. I wish I could get rid of this space here. If I could put light and then dark afterwards, then this string would only be 9 characters long, and it still would work. If you tell BASIC to print 5 characters and there's only 4 remaining, it will still just print the 4. There's no error or anything. So that would work, but the problem is we would have to reverse A. Well, of course, we got rid of the A variable here, but we would have to reverse the math, and I couldn't figure out a way of doing that without using at least 1 or 2 more characters, and we're only saving 1 by switching the order. If you can think of a way, then there might be a savings there. It'd be nice to get rid of some of this math, but I don't know. I tried to get rid of another pair of brackets, but I could not figure out how to do that. So there still might be room for you to improve this. Oh yeah, so one other thing, if we run that, we type in A1, it is actually printing dark with a space after it. If that bothers you here, like if I put a couple X's after there, hit run, A1, you see how it printed dark and a space? I guess strictly speaking, that isn't the same as just dark. So if that really bothers you, we could do this. You insert a space here and then press stop, and it will put in a reversed C. And that's the control code for stop, related to break, if you know control C on other systems. Okay, and now if we run it, A1, dark, if we print a couple X's after it, and we'll run that again. You see, this time it really did just print the string dark. I suppose it printed a stop, but that's invisible, so it doesn't matter. So there's a little fix in case, strictly speaking, dark with a space at the end isn't the same as just dark. Okay, so how short can we get this if we use abbreviations? Well, we already talked about we can't get rid of input, but we can get rid of that leading space. We can change the print into just the question mark. We can change MIDI into M-Shift-I. Here I'm going to change to lowercase so it's clear, M-Shift-I. And we can get rid of both the D and the $sign because those are burned in to the abbreviation. We'll leave dark light the same. ASCII is A-Shift-S. Value is V-Shift-A. Midstring is M-Shift-I again. And is A-Shift-N. Okay, so I think that's fully abbreviated. Just to confirm it works. A1, C2. So that is 40 characters. 41, 2, 3, 4, 5, 6, 7, 8, 9, 50. 1, 2, 3, 4, 5, 6, 7. 57 characters. So I looked on that Code Golf site that Shaun had shared. So how does our 57 bytes compare to other languages? Well, Python 2 can do it in 38 bytes. Print, and it's done some tricky interleaving of the words light and dark. Wow. So Python 2 and 38 bytes. GS2, 15 bytes. I don't even... What? D-E... What is that symbol? It's like a diamond and a spade? I don't know. How does that work? Hexagony manages it in 32 bytes. That is cryptic. Okay, TI BASIC, I know that one from the TI-84 calculator. 66 bytes. Hey, take that, TI. Just like TI versus Jack Tramiel, TI loses. Oh, and here, Java, 124 bytes. How appropriate. Oh, bloat. Okay, and C manages it in 55 bytes, just 2 bytes better than my best C64 BASIC one. I'll take that, but maybe one of you can get it even shorter and even beat C. And of course, we beat Java no matter what. Okay, so thanks very much to Shaun Bebbington. Shaun finds a lot of interesting low coding challenges like this and posts about them. I think it was on Facebook. I saw that he posted this. So thanks very much, Shaun. I enjoy a lot of your posts about coding and so on. Okay, thanks to Aiden for making up that original challenge. Thank you to all my patrons so much for your support. And thank you for watching. We'll talk to you next time.
I'm seeing those games everywhere. At the laundromat, at the grocery store, at Grandma's restaurant. But none at home. This place without a computer. At the corner store, at the roller skating rink, at the pool hall, at the mall. Why can't it be for me? I saw their phosphorus glow. I saw the new worlds, places I've never